Okay, hi everybody. So today is Wednesday, March 20th. So last class we finished session 8.3. I hope you have finished most of your homework because the homework 8.3 is due tonight. And you also have quiz 3 due tonight. So quiz 3 is mainly about 8.3. Okay, everybody? So today we will also start 9.1. Your exams 2 is about chapter 8. So 8.1, 8.2, and 8.3. So the exam is going to be next Monday. So, bless you. So next month, next Monday, I also have I teach another class right after our class here. They also have exams. So if you need more time, you just stay longer. Okay, and yeah. So so that's exam 2. And so I hope that you can, if you need help, ask me. Visit my office hours more often this week. And this Friday afternoon from 3:10 to 5 p.m., we will have a study session right here. Okay? So I hope you can. Friday, 3:10 to 5 p.m. So, yeah, tonight you have the homework 3 and the quiz 3, and then Thursday and Friday work on your practice exams. So if you have questions, you can ask me on Friday. Okay, everybody? Yeah, I hope to see more students. What happened to them? Okay. All right. So that is our plan. So before we go to 9.1, I would like to have a look at the practice exams with you so you can see what types of problems going to be on the exam 2. Okay. So this is the practice exam. Problem 1, you're going to sketch the graph of the function y equals 3 sine 2x minus pi minus 4. So we learned the graph of all the 6 trig functions, right? The methods are very similar, right? You draw the table with 4 columns. They are x, theta, and the trig function theta, and then the y. Yeah, everybody? And so you first fill with the, by the way, in the exam, I will give you this chapter A formula sheet, but blank. So you can spend 2 minutes to fill out the sheet, and then when you do your exam, you just look at the numbers on the sheets. Okay, so you first fill out the column of the theta and the trig function theta. Right, everybody? Mm-hmm. So you have 6 different ones, and after that you find the x and also find the y. Remember, after you find the x and y, you can plot those points on the xy plane, right? And depends on what the x is. So let's say if your x is let's say the biggest is 6 pi, then your scale you want to draw more positive numbers, and you have the biggest is 6 pi, right? Or if your x is negative pi over 2 to 0, okay, the range, then you draw more about the negative side and make the pi over 2 spread bigger. Okay, so look at the x values to design your grid, how much scale you need. Okay, and then you can sketch them. So this is the first type of problems. So you have 6 trig functions, right? I will ask you one problem is either sine or cosine. So in the practice exam, I ask you sine. Maybe the actual exam, it could be sine or it could be cosine. And then one problem is either tangent or cotangent. Is that clear, everybody? Yeah. And one problem is either secant or cosecant. Okay? But I won't tell you which one I pick. So be prepared. You will have 3 questions about the 6 trig functions. Okay, and then these type of problem, if you have the inverse trig function of some number, you need to draw the picture of the trig function. So last time I give you the notes, the reference angle in the trig graph, right? So you look at the graph, for example, here, what is that? Cosecant. Okay, if you have cosecant, you can convert it to what? Sine, right? Because sine is the reciprocal of cosecant, right? So then you get oh, this is like a sine of the reciprocal, negative root 3 over 2. So then you can draw the picture, you know, the special angle values in the first quadrant. And then you see, oh, negative root 3 over 2. By the way, when you draw the sine graph and the inverse sine graph, you need to draw it longer. Okay? Because the 1-to-1 piece of the sine function is from minus pi over 2 to pi over 2. Okay, everybody? So in the exam, in order to get all the 5 points, don't just give me a number. You need to show all your work. You need to draw the graph. And then, so I can see what is, if you let y be negative root 3 over 2, what is the corresponding x? Is that clear, everybody? Mm-hmm. Similarly with like arc cotangent. Okay. But then problem 5, when I say use your calculator to compute, you don't need to draw the graph. Use your calculator. But your calculator only has sine, arctangent, and arcsecant. So if you have arc cosine, arc cosecant, arc cotangent, you need to convert it to arc sine, arc tangent, and arc secant. Yes, everybody? Mm-hmm. Okay. And then problem number 6. By the way, if you're late, you missed the first 8 minutes, could you promise me you will watch the recording? Because I don't want you to miss any information. Let's see. I have some handouts here. Who didn't have this? So today you have homework 8.32 and you also have quiz 3, okay? Don't forget to do them. So, and watch the recording, don't miss any information. Okay, so yeah, this type of problems, you need to draw 2 graphs. So like this problem, you need to draw the cosine graph and the sine graph, okay? So yeah, review the exercise from 8.3. Yes.
For 6B, do we have to draw the graph because they cancel?
They don't cancel because the 1-to-1 piece of cosine is from 0 to pi. And this is not from 0 to pi. So you have to find the corresponding x from 0 to pi. So here, this problem, if you just cancel and say the answer is negative 5 pi over 7, that would be wrong. Yes. Okay. Why don't I tell you the answer of this problem so you can see? All right. So, like here. Okay, this is the graph of cosine. And negative 5 pi over 7 is here. That's your x. But then, what is the 1-to-1 piece that we restrict? We restrict to 0 to pi. Okay? So if you get this number, you have to draw a horizontal line and find the x with the same y value, but in this range. So you draw the picture, you can see, oh, I have the same length, but positive. So we realize, oh, this is 5 pi over 7. Is that clear, everybody? So this is what it means if you draw the graph. they don't just cancel. And you can see they're not just cancel. You don't have the same x. Okay? You find the corresponding x in the one-to-one piece domain. Okay, everybody? Yeah, so yeah, do the practice exams Friday afternoon, 3:10 to 5 p.m. in this room. We have study session. Okay, so you can ask me questions. All right. And then this problem. Okay, so all this type of problem, if you have the inverse trig function outside, then you need to draw the trig graphs. Yes, everybody? What? If you have the inverse trig function inside and the outside is a trig function, you only use one method. That is triangle. Draw the triangle. And do you need to care about like which trig functions? No, just one method works for all. Okay? Draw the triangles and then label them. Okay, yes. And this is also similar, draw the triangle. And this is a story problem. So like the class we did last time, you draw the picture and then you find the corresponding side and the angle, then you do the inverse trig function, you can find it. And this is more exercise. Okay? Any questions about
There's a problem 9 too.
problem 9? Oh yeah, thank you. So we're gonna solve the triangle. Yeah, so this is the triangle with the side A and C, and the angle C is 90 degrees. So you can draw the picture and you find all the side and all the angles. On all the side, the remaining side, you can use Pythagorean theorem, right? And then you look at the relation to figure out the appropriate trig functions. And then you do the inverse trig function to find one of the angle. And then the remaining angle is 180 degree minus 90 degree minus that angle. Right, everybody? So we also do that last class. If you miss a class, make sure you watch the recording. Because, yes, and this is just more exercise. Mm-hmm. Any questions? So you have seen all this type of problems in the notes. Okay, so now just add some variation. You change the different trig functions. Okay, yes. All right. So, and before we go to 9.1, how about we also play a Kahoot game? Actually, I'm developed a lot of Kahoot game, but unfortunately, we didn't have time to play them all. I think we played like 7.2 and 8.1, right? So, yeah. Today, let's play 8.3. Oh, yes, thank you. Did my alarm ring? And I just turned it off? Thank you. Okay, so take out your phone. All right, start. So go to kahoot.eats, enter the game pin, or scan the QR code. If you have scratch paper next to you, yeah, do that. Uh, or you can maybe take out the formula sheets, like these ones. Do we have more student drawers? More? Mm-hmm. Everybody ready? Do we have more people? Okay. Yes. Okay, so everybody ready? Yes. Okay, let's start. And questions. What is x? Sine x is 1/2. It actually has more answers. Look at all of them. All right. Did everybody answer that? How many students do we have? Pi over 6 and 5 pi over 6. Why? So that's why I see. Look more. Okay, this is the sign. And you see here, 1/2. 1/2 is here. When you draw a horizontal line, do you see it's actually 2 points? This point, this point is pi over 6. How about this point? Do you remember the reference angle sheet I gave you? This is the reference angle theta, and then this corresponding one will be pi minus theta. In this case, your theta is pi over 6. So this point is pi minus pi over 6, which is 5 pi over 6. Is that okay, everybody? Mm, yes. So it's not just one number, it's actually two numbers. Okay. All right. Next. Yes. What is tangent x? You have 2 minutes. Draw the picture. Or you can look at the picture of the formula sheets. This problem might be like longer. Yeah. Do you still remember from exam one, you have your cosine in terms of x, y, r, and then you let the x or let the y or let the r be something, and then what over what? X over x is -3, and this is 5. Okay, then this is gonna be 4. Okay, so then tangent is what? Opposite over adjacent. So negative 4 over -3. And that's why we get this. Oh, 8 of you get this right. Good. Okay, again, what is x? Cosine x is √3 over 2. Find the x in 3 pi over 2 and 2 pi. You need to look at the picture of cosine. Thank you. Actually, there's an easy way to look at the answer. Which angle is between 3 pi over 2 and 2 pi? There's only one answer, right? This is in which quadrant? 3 pi over 2 to 2 pi. Quadrant 4. Yes, quadrant 4. Where's the picture? Like here. See? You have like root 3 over 2, right? And then in quadrant 4 it's gonna be this one. And then root 3 over 2 corresponds to pi over 6, right? And then the reference angle is pi over 6. Then what is this? 2 pi minus pi over 6, which is 11 pi over 6. Okay, everybody? So use the reference angle and the trig graphs. Okay, so 5 of you get this right. Good. Next. Again, what is x? So cosecant is negative 2 over 1. So if you see cosecant or secant, convert it to sine, cosine. And you want to find the angle in quadrant. What is the quadrant between pi and 3 pi over 2? Yes, quadrant 3. Do we have one student? Everybody? Huh? Okay. Yeah, 7 pi over 6. So y. Okay. Cosecant is negative 2. What's the reciprocal of cosecant? Sine. So sine is negative 1/2. Look at the sign. Negative 1/2. It's like here, right? And then you look at, oh, this is the corresponding x values in quadrant 3, right, everybody? And negative 1/2, okay, 1/2 corresponds to pi over 6, right? Then this is going to be pi plus the reference angle pi over 6, which is 7 pi over 6. Is that okay, everybody? You look at the number, find the reference angle, and then you can find the corresponding values. How about if I ask you to give me the angle in quadrant 4? This will be 2 pi minus pi over 6, which is 11 pi over 6. Okay, everybody? Yes. So we actually have two x values give us the same y values. Okay. All right. Next. Okay, good. Find the exact radian value. Which angle? And there's only one correct answer. Yeah, that's right. Okay, questions. Why don't we choose the 2 pi over 3? Okay, notice that pi over 3 is like here, right, everybody? And the 2 pi over 3 is here. They both give us sign of those x equal to root 3 over 2. But however, the upside range is the domain of the sign, which is the restricted domain. So we have a 1 to 1 piece. Our restricted domain is from negative pi over 2 to pi over 2. So that's why you cannot pick the angle here in the second quadrant. Is that clear, everybody? Mm. All right. Good. All right. Find the exact radian value at cosine root 3 over 2. You have one more student? Everybody finish? Okay. Oh, good job. So cosine. Look at this picture. The 1 to 1 piece we restrict is from 0 to pi, right? So therefore, yeah, root 3 over 2 corresponds to pi over 6. Yes. Good job. Okay. Find the exact radian value at tangent 1. It's at tangent 1. Why don't you please make my picture bigger? Okay, one more student. Yes, pi over 4. So tangent, right? You have the special angle values. Tangent pi over 4 is 1. Tangent pi over 6 is 1 over root 3. Tangent pi over 3 is root 3. Okay, everybody? So if I tell you what is arctangent of negative 1, negative 1, it'll be negative pi over 4. Okay, everybody? Mm. So continue. Good job. Again, find the exact radian value. A sine of 1/2. Mm-hmm. Good job. Yes. Okay. Let's find the exact radian value. At cosecant -1. So, cosecant, the reciprocal is a sine of reciprocal of -1 is still -1, right? So, and then here, when you do the sine, you have to draw longer, right? And you plug it, -1 here, I should draw it here. -1 here is corresponds to this angle is negative pi over 2. Okay, everybody? So you can draw the sine function longer. Then you can see it. Okay, good. Let's see. Okay. Last questions. Last time, root 2 over 2. Do we have everybody? Oh, so, okay, yeah, pi over 4. Let's see, where is it? Okay, yes, here, root 2 over 2, like here is pi over 4. But if I tell you negative root 2 over 2, then your answer will be negative pi over 4. Okay, everybody? Okay, if I say, give me the x values in the second quadrant of root 2 over 2, what do you guess? What's this? 3 pi over 4. Yes, everybody? Okay, by the way, this is so important. You will see this again in section 9.5. The next chapter, we will talk about 9.5 is solve equation involving trig functions. And you end up getting find all the x values such that sine x equals to a number. Then you look at the picture and you find all the x values, not just a single value, but all the possible x values. Okay, everybody? So keep this sheet with you. It's very important. All right, let's see. Podium. Third place. That's well. Second place. Yay. And first place. Hi. Good job. And we also have Sophie and Emily. So homework 8.3 is due tonight. And also the quiz. Don't forget to do the quiz. And I have office hours from 11 to 1:50. So if you have any questions, please come to ask me. Any questions about chapter 8? No? Okay. Are you ready to start 9.1? Okay, let's take out your 9.1 handout. So 9.1 is about fundamental identities. Well, all these identities we have learned before, right? Yeah. So you remember our hexagon? Yeah, hexagon right here. Look at the diagonal, then we get the diagonal formula, right? Look at the triangles, we get the triangle formulas. So they are the trig identity. So yeah, the reciprocal identity is like the diagonal, we know that. And quotient, tangent is sine over cosine. Right, everybody? And cotangent is reciprocal, so cosine over sine. And the Pythagorean identity is like the triangles, right? Yes? So, how about these? The cofunction identities. Remember theta and 90 degree minus theta? They are complementary angles. Do you still remember complementary angles and supplementary angles? Complementary angles, you add together, you get 90 degree. Supplementary angles, you add together, you get 180 degree. Yes. So we have the cofunctions. So sine, cosine, yeah, of complementary angles are the same. And similarly. Tangent, cotangent, and secant, cosecant. This is the cofunction identities. And negative angle identities. Who are hungry and eat the minus sign? Cosine and secant. Okay, everybody? Actually, this is also related to odd function and even function. Look at the picture. You see the sine, odd function, right? Everybody? Cosine, even function, eat the negative. Yes, everybody? Tangent, odd function, right? Cotangent, odd function. Secant, what? You can draw longer. Even function, eat the negative sign, right? And cosecant is also an odd function. Okay? So odd function, you still have the negative sign you can put in front. But even function, you eat the negative sign, it disappears. Digest. Okay, everybody? That's the negative angle identities. Okay, so we call if you have problem like cosine theta is 5 over 8 for theta in quadrant 4. Find the values of the outer trig function. So this is like what we did before, right? You look at the xy plane. All right, so let's do this together. This is like this problem we did it before in chapter 7. Okay, so let's recall how we did that. All right, so okay, so we draw the. What happened? Okay, so we draw the x and y and cosine theta in terms of x, y, r. What over what? X over r, right? So because it's gonna be in quadrant 4. That's quadrant 4. That's theta. So sorry, that's not theta. Theta is actually from here to here. Okay. And now you can let x be, what is x? Compare. X is 5 and y is, sorry, not y, r. Yeah, r is 8. Okay, so x is 5 and r is 8, and we're looking for the y. Is that okay, everybody? Mm-hmm. Yeah, x is 5 and r is 8. And now, how do we find the y? X squared plus y squared is r squared. So y is plus or minus? Yes, r squared minus x squared. Let's wait until everybody finishes writing. Do you still remember these kind of problems? Yep. Okay. R squared. R is 8 minus x squared. X is 5. What is 8 squared? Yeah, 64. 5 squared, 25. Oh, what is 64 minus 25? Thank you, 39. So here, you need exact values. Can you plug in your calculator and put a decimal there? No! Leave your answer in exact. And because, theta is in quadrant 4, our y is negative. So y is negative square root of 39. Okay? And you ready? What is sine in terms of x, y, r? Y over r. Y is negative square root of 39. R is 8. Yes, everybody? Still remember? Okay, now you write the rest. We get sine, and then cosine. We already have cosine. And what is tangent? And what is cotangent? What is secant? Okay, what is tangent? Yes. And y is negative square root of 39 over x is 5, right? And we know that cotangent is the reciprocal of tangent. Reciprocal. So we get 5 over negative square root of 39. And then what is secant? Yeah, secant is 1 over cosine. So it's 8 over 5. Okay. And cosecant is reciprocal of sine. So 8 over negative square root of 39. Right, everybody? You still remember how to do this type of problems? Yes. So I can change to any trig functions. And then you look at the relation in terms of x, y, and r. You can draw the point and draw the triangle. Use Pythagorean theorem to find the remaining side. And then you can look at the angle in which quadrants, determine whether it's plus or minus. By the way, R is always positive. X and Y could be positive or negative, depending on the quadrants. Okay, so number 2, express the tangent function in terms of the cosine function only. Okay, so what is tangent? Yes, sine theta over cosine theta. But we want to express in terms of cosine only. Oh, denominator is cosine. That's good, right? But the numerator is not cosine. Can we express sine in terms of cosine? Yeah, look at the identities. Which identities involve sine and cosine? Yes, questions?
Will these identities be worksheet for us to use inside of the exam?
In the exams, you will have this. You will have the hexagon. So once you have the hexagon, you look at the diagonal and you can get the reciprocal identities. And you look at the triangles, you get the triangle formula. And then you also remember tangent is sine over cosine. Yes? Right. Okay. So yeah, you have like the blanks sheets. Okay. So yeah, that's why I suggest you spend 2-3 minutes to fill out the formula sheets. Then when you work on these problems, you just look at which one has the which one you want to use. Okay, we know that sine square plus cosine square is 1. Right, everybody? This formula has the sine and cosine. We want to solve for sine in terms of cosine. How do you solve for sine? Yeah, subtract cosine square. We get sine square It's 1 minus cosine square. Right, everybody? What do you do next? Square roots. But when you take square root, you get plus or minus. Right, everybody? Every time you take square root on both sides, you get plus or minus. Therefore, the answer, now you can put it here. You get plus or minus square root of 1 minus cosine square over cosine theta. Is that okay, everybody? Now we express everything in terms of cosine. And even any trig functions, you can always express in terms of sine and cosine. How? You know, sine is sine, cosine is cosine. But tangent is sine over cosine, right? Cotangent is cosine over sine. Secant is 1 over secant, 1 over cosine. Cosecant, 1 over sine. So you can express everything in terms of sine and cosine. Okay, everybody? That's why this is like one trick because we're more familiar with sine and cosine. And you know sine squared plus cosine squared equals 1. Okay? Yeah, so let's continue next class. And today you have homework, 8.3, and quiz. Yes. The homework you submit the first attempt, but you can still work on it after the deadline. But the quiz, yeah, you have to submit your quiz by midnight. Mm-hmm. Okay, and I will be in my office from 11 to 1:50. If you have questions, come to see me. And tomorrow, work on your practice exam. Friday, come to my office hours and join our study session in the afternoon. So you're ready to take the exam on Monday. Have a good day.
Our meeting today, can we change that to Friday?
Sure.
We have my church service today.
Yeah, sounds good. Oh, let me stop recording.